Recording. Welcome, everyone. We're recording. Okay, here we go. I'm gonna need a light person. Pull up on. Yes, please. Okay, everybody at home can see this. Let's see if I can make it bigger too. That's bigger. Huh? All right. Does it come up? Good. Here we go. I'll start it out. Arc welding safety. Arc welders use a powerful electric arc to make and repair plain, coated, or treated metal items. Welders can be stationary, electric powered, or portable, diesel/gas powered. I'll read this paragraph too. Install electric powered arc welders to code ground equipment and place it on an independent circuit with the correct size fuse or circuit breaker. Overloading circuits or improper installation can lead to a fire, a ground fault, or equipment failure. Mount a safety disconnect switch near the user work area. Operate diesel gas powered arc welders in well ventilated areas to control combustion fumes. Do not add fuel to the engine while it is running or near an open flame. Stop the engine, lock out the ignition before performing maintenance or repairs. John Tappy.
To protect your body from burns due to arc welding heat, ultraviolet light UV, molten metal, and sparks, wear dark colored coveralls with long sleeves and pant legs. The coveralls should be fire retardant, cuffless, and pocketless with no holes, tears, or worn spots. A skull cap protects your head and hair. Leather gauntlet, gloves, and safety boots protect your hands and feet. Wear hearing protection in noisy environments and to keep sparks out of your ears.
Mike Silva, John's other brother.
Goggles or safety glasses or welding helmets, shields.
Mike, you there?
Yeah, you got some sound on.
Shit. Sorry, Mike. Let me turn you up here. Mike, can you unmute yourself?
Yeah, can you hear me?
I can hear you now.
All right. Goggles or safety glasses and welding helmets/shields protect your eyes from flying sparks, chips, slag, and UV light. Welding helmets and shields should be non-reflective and free of cracks, gaps, and openings. Use the correct filter setting for the output of the arc welder. Weld inside a screened area to protect coworkers. Portable screens, shields, and anti-flash goggles can also be used to protect visitors and coworkers.
Miguel, are you out there? Can you read the next paragraph? Arc welding.
Arc welding can reach temperatures greater than 10,000 degrees Fahrenheit,
10,000 degrees. Holy smokes. Go ahead.
posing a fire and explosion hazard. Do not arc weld near flammable or combustibles. Avoid welding, cutting, or hot work on used drums, barrels, tanks, where residual fumes can ignite and explode. Weld on a fire brick surface, on concrete or other fire-resistant forms surrounded by spark curtains. Fill cracks in the flooring to prevent sparks and hot metal from entering and smoldering. Keep an ABC fire extinguisher, fire blanket, and first aid kit available at all times. It may be necessary to set a fire watch to ensure that a fire does not start.
Thank you. Matthew?
To avoid electric shock from arc welding, use a insulating mat when you weld.
Yeah,
Steel or other conductive materials. If you are welding in a wet or damp area,
Sorry.
perspiring heavily, wear rubber gloves underneath your leather gloves. Keep welding cables clean, intact, and position them so they do not get sparks or hot metal on them. Use arc welders in well ventilated areas. Welding metals may be hazardous or lead to an oxygen deficient atmosphere and are best handled in a ventilation hood exhausted to the outside. If you weld or cut metals with hazardous coatings or treatments, use a supplied air respirator or a respirator with a specialty cartridge to filter specific metal fumes. Use respiratory protection for galvanized items and metal coatings and fluxes that contain fluorine, compounds, zinc, lead, beryllium,
Beryllium.
cadmium, and mercury. Some cleaning and degreasing compounds may also be hazardous.
Okay, and I'll finish it with the above evaluations and the recommendations are for general guidance only and should not be relied upon for legal compliance purposes. They're based solely on the information provided to us and relate only to those conditions specifically discussed. We do not make any warranty expressed or implied that your workplace is safe or healthful or that it complies with all laws, and regulations. So any comments or questions about all that stuff? Lou, and would you turn on the lights too, please?
Yeah. How do electric arc welders work?
The same way gas ones do. They gas ones develop power, electricity, because it's an electric arc. It's a charged. Your welding rod and welder is charged, and when you touch metal, it creates this incredible heat, and then it melts the rod and it melts the metal together, and it causes a weld. So it's done with electricity. So arc welder pretty much needs 240 volts to a plug-in arc welder, which limits you to shops. And so if you're in a shop, typically your arc welders, your Lincoln arc is a big maker of arc welders. It's going to be a stationary tool with 220 Runduit and conduit. If you're out in the field, it's not that easy to get juice unless you're carrying a generator. So there you have a gas or diesel fired one that basically generates the juice it needs to be able to arc weld. Now, the thing about arc welding, besides all the stuff that they talked about, that's kind of obvious about the heat and the flammability, because we're talking about 10,000 degrees here. It was 93 today. So even if it got to 100, that's insane, man. That's like what? It's 10,000 times hotter. It's really hot. And so you can burn things really easy. Sparks can get in. If you're on a plywood floor, bad idea. You got any cracks, if you're any sawdust, not a good idea to weld. Anywhere near there's sawdust or anything that's flammable that could ignite because so much heat is generated, and you really got to protect yourself because there's a lot of sparks and stuff like that. It's even more intense than an oxyacetylene welding, because you can also get electrocuted as well, working in a wet area or something like that. But the thing about welding is you can't look at the weld. You can't look at the weld. It will fry your retina. You can only look at it with special glasses. The only way you can look at a weld is with special glasses. If you look at a weld without special glasses, then you will fry your eyeballs. Now, I'm not talking about a glance. I'm talking about looking at it. And that's from 15 feet. You can fry your eyeballs from 15 feet. So be very careful if you're around arc welding. It's dangerous stuff. It's great stuff. Arc welders, they arc weld underwater. Oxyacetylene too. Oxyacetylene weld underwater too. I wanted to tell you that the whole thing about wearing rubber gloves under your leather gloves and insulating yourself from shock and working on rubber mats. I wish I had known a little bit more about that when I was working in this place in North Hollywood, 1968, I guess, 67, 68, a place called Thermo Labs. And Thermo Labs made aircraft heaters for aircraft. And they're really small. So a typical heater was about this wide and about this long and about that thick. And it was metal, and then I had all these fins in between. And it would get it would be blasted clean metal, and I would spray a beryllium based paint. It was basically ground up beryllium. Well, I'm sorry. It's a ceramic paint, and the ceramic went in as powder and some, solvents, and then it went into a canister and rolled overnight with these beryllium balls, which ground up the glass, made it liquid, and so it could be sprayed. And then it went into a kiln, and it got baked, and I forget what, and it came back glass hard, right? And then it would get tested for hypox, and as long as it coated the whole thing, it'd be cool. And then it'd be masked by these ladies, and then I got to this job too. Then you would spray 2 strips of silver, nickel, lead, and zolol and toluene and some really nasty stuff. That's how they were made. It was a horrible shop. It didn't have adequate ventilation. I would just be hawking the stuff out of my nose every day. Thank God I didn't work there very long. I was too young and dumb to know much better. But one of my jobs was if the initial, this yellow glass paint, if it had a high pot, and a high pot would be somewhere where there was a flaw in the paint, and you couldn't run electricity over it, it would short it, and those would get set aside, and they wouldn't get dumped, they would just get sandblasted clean. So I'd have to take a bunch of them out and then blast all that paint off, get them clean, and then they could be done again. Hopefully this time, right. The sandblaster is a big machine, electric machine, right, with a big window and then big arms, right? You put your hands in through the arms, the rubber arms, and you hold your stuff under a nozzle. And the nozzle's blasting out this sand, right? And you hold it, and turn it, and get it all blasted. Well, what happens inside of there is a boat ton of static electricity. All those beads, right? The air is charged with static electricity. I had a hole in my glove. So the static electricity went through the hole in my glove and grounded to me on the floor. And basically it just, bam, it slammed my arms so hard into that, when I got the shock. And then it did it like 3 or 4 times. I mean, I was black and blue for a month. Just from a little hole in those gloves. Because you're working with them, and brought to mind, because when you're working with things like sandblasters and arc welders and industrial type equipment like that, there are hidden,
Dangers.
hidden dangers. Not the word I was looking for, but that does it. There's hidden dangers that you can't even anticipate. So try to find out everything about what it is you're doing so you can do it safely. That's the most important thing, is don't get hurt, do it safely. If you have to slow down, if you have to take your time doing stuff, I was building this restaurant that's now the Natural Cafe on Hitchcock. When it was a brand new building. It had just been built, and we were building the booze, and I was shaping all this mahogany and making this wainscotings and stuff. What was I telling you this? Say again?
Say any safety issue or hazard or any accident that you have, perhaps?
What was I telling you?
Temperature?
It'll come to me. But it's gone now. So, yeah, gone, totally gone. Oh, and I was going to tell you about mercury. So I mentioned mercury, right? Mentioned, you can be welding stuff that's coated with things that when it's heated, it releases a gas that can be really toxic. So you need to know about stuff like that, the coatings and what happens to them at 10,000 degrees, because they basically vaporize. And when they vaporize, that means the coatings turn to vapor. And that vapor could be breathed by you. That's why they talk about respirators. So mercury, right? Everybody knows what mercury is. It's used in a lot of things. It's the 3rd heaviest element. Mercury is on the atomic scale, the 3rd heaviest element. Now, you've heard a lot about mercury poison and mercury fish, mercury poisoning. Well, the real nightmare mercury deaths happen in the late 1800s and early 1900s, when in the plants that they smelted mercury in. So mercury is mined as an ore called cinnabar. Cinnebar, cinnabar. So cinnabar has mercury in it and it needs to be smelted. So it needs to be busted up and heated, and then the mercury becomes a vapor and it's distilled into the liquid, back into the liquid, that silvery liquid form, right? And before we had a lot of controls on manufacturing, before basically we had no controls, that vapor would not be captured well, and it would get in the air and it would be breathed by someone nearby, a human. Those droplets, that mercury vapor, condenses in your sinuses and in your lungs and become small drops of mercury. And then the mercury would drop through your body. And it would take years, but it would perforate your organs super slowly. It was agonizing. So don't ever breathe mercury vapor, okay? And try not to get any jobs in cinnabar smelting mines. I don't know what they're doing now, but you know they got big time controls. It's probably all robotic now. Yeah, that was an interesting factoid, isn't it? It's amazing it's locked in that head of mine. So we finished with multiplying fractions. And we didn't get to dividing fractions. We're going on to dividing fractions. And then when we get through dividing fractions, tonight we'll go right into decimals. And then we're going to start getting into some meaty stuff. Once we get into decimals and converting decimals and using decimals, then I'm not sure where the book is going after that. But then we're going to start doing area measurement, units measurement, doing some takeoff. I might break off and do a little takeoff with you now. But let's go to the book. We'll open your book to I think it's unit 2, section 8 or 9. So, I think it's maybe section 2, unit 10. Share screen. Oh, unit 9. Okay, we did multiplying fractions, right? We did 9. So we're going to 10. Can you guys at home on Canvas, if you're on your computer, are any of these units available to you to pull up? Just curious. Remember, didn't somebody tell me that just 1 and 2 came up and nothing on the others? I haven't checked, but if I do check, if I go, no, I'm not going to do it. Let's just go to 10. Let's go to the online unit 10 textbook checkbook. Let's go to the checkbook. Guys, bring your checkbooks. You won't need them.
All right, unit 5, or is it 5 or 9?
It's unit 10. Yeah, 9 is multiplying. We got through multiplying. We're doing 10. We're going to learn how to divide fractions. So the objectives after we get through this this guy here, this unit, is we're going to demonstrate the method used to divide fractions. We're going to solve dimension problems containing mixed numbers. Remember what a mixed number is? That's a whole number and a fraction, as opposed to a common fraction and an uncommon fraction, which we're going to see those two. So once the process of multiplying fractions has been learned, dividing fractions becomes easy to learn by adding one simple step to the process. The method used to divide fractions. When performing a fractional division operation, the fractions are set up horizontally and are separated by the division symbol. So in this case, it's 7/9 divided by 4/5. That would be that's the problem we're looking at. What's the answer? First step in solving the equation is to find the reciprocal of the divisor. So the reciprocal is the value to multiply a number by in order to have a product of 1. To find the reciprocal, simply invert the fraction by switching the positions of the numerator and the denominator. For example, the reciprocal, the divisor, in this case, in the problem we're looking at, 7/9 divided by 4/5. The divisor is the 4/5. And if we want to divide into 7/9, all we got to do is we got to find the reciprocal, and we just change the 4/5 to 5/4. And then we do the whole thing like we've been doing, just like, and then you multiply, right? So math tip, the reciprocal of whole numbers can be found as easily as that of fractions. Remember that a whole number can be represented as a fraction that has the whole number as the numerator and 1 as the denominator. For example, 4 equals 4 over 1. By expressing a whole number as a fraction, the reciprocal becomes more clear. For example, the reciprocal of 4 ones is a quarter. And we'll do more. If that's confusing, you'll see it a little more. So after the reciprocal has been found, the division problem becomes one of multiplication. Multiply the dividend by the reciprocal of the divisor to find the solution to the equation. Simply put, that one that we just started out with, 7/9 divided by 4/5. What we do is we go 7/9 divided by 4/5 equal 7/9 times 5 over 4. So we found the reciprocal by just inverting the numerator and the denominator. Simple stuff. Whatever is dividing into, that is the second number. So 7/9 is being divided by the 4/5. Just reverse it, make it 5/4. And then we do the multiplication, easy multiplication. So 7 times 5, because we can't cancel anything in there either, right? 7 and 4 have nothing that go into them equally, and 9 and 5 also have no numbers that go into them equally. So 7 times 5 is 35, and 9 times 4 is 36. That is the answer, 35/36. So the answer to what is 7/9 divided by 4/5 is 35/36. Simple. It's a very simple equation. Just got to remember to take the divisor and invert the numbers. Let's just keep going. Here's another example. So we want to know what 1/3 divided by 5/12 is. And so what we're going to do is we're going to just change that to 1/3 times 12/5. We can do some canceling on the next line down. We can cancel the 12 and make it a 4 because 3 goes into 3 one time, 3 goes into 12 4 times. Then it's 1 times 4 and 1 times 5, which is 4/5. That's the answer. That's the answer to 1/3 divided by 5/12. When dividing fractions, invert the divisor and change the operational symbol from division to multiplication. It's that easy. Just invert the divisor and instead of dividing, then multiply, just like we did learn to multiply fractions. It's almost like magic. I mean, isn't that kind of magical in a way? It's like, okay, sure, I'll do it. I mean, they've explained kind of why, but not really. But the truth is, I don't really care about why. I just know that it works. And after we get through this, we're going to get right into decimals because I rarely, if ever, divide or multiply fractions. I pretty much always convert them to decimals, and then I'm working with basically whole numbers. The decimal might be somewhere in between, but not fractions. And I think that's where the book is going to take us. So let's divide mixed numbers. That's another ballgame. So as with other operations, when dividing fractions with mixed numbers, the fractions must first be converted into improper fractions, then perform the division on the improper fractions. So here's an example. All mixed numbers in the operation are converted to improper fractions. So 2 5/8 divided by 3 2/3. We have to change both of those mixed numbers to uncommon fractions. So 2 5/8 becomes 21/8 by simply going 8 times 2 is 16, add the 5 on top, 21/8. The 3 2/3 becomes 11/3 by simply doing the bottom number times the whole number. 3 times 3 is 9. So there's 9/3. And then we're adding the 2/3 that are on top, giving us 11/3. Now we're going to change that 11/3 to 3/11 and multiply. So 21 times 3 is 63, and 8 times 11 is 88. And you notice that in the 21 times 3 and the 8 times 11, there's no canceling. Wait, you guys aren't seeing this. I'm sorry. You should be seeing this. I knew I was doing something wrong. Can we unrecord that? No, impossible. Lights, please. At least one. So let's see if we can see it on one. It's still pretty light out. Let's try 2. Yeah. Yeah. Okay. Okay, and if you guys need the light to make notes, we'll turn one back on. But right now, we can see this pretty good. You know what? Go ahead and turn one back on. And let's see if it, now that it's come up to speed. You guys can still see it, right, with one?
Is this better or is this better?
That's it.
Wait, start, which one now?
So is this better or is this
Wait, do it again.
Similar.
I'm sorry, I can't tell the difference. Can the folks at home tell the difference? I don't think so.
better?
Okay, so now you guys can see all this stuff I've been talking about. I'm so sorry. Why didn't somebody say something?
I think one.
So let's look at example number 10-3. Oh wait, we just did that. 63 over 88. So let's do another one. Let's do another one. Let's do example. Okay, let's show the following equations and let's reduce the answers to their lowest terms. And we'll try to do these without writing them on the board because you guys are looking at that. They're looking at that. So see if you can make sense of this. So 5/12 divided by 3/4. What do we got to do? We got to flip over the 3/4 into what? Make it what?
4/3.
And then do we divide then or do we do what? We multiply, right? So we flip that over. And so now it's 5/12 times 4/3. Okay, so the 5 and the 3 we can't cancel, but the 4 we can make that a 1 and 4 into 12 goes 3. So we got to cancel there. So then we'll do the multiplication across. 5 times 1 is 5 over 3 times 3 is 9. The answer is 5/9. That's the answer. That's the answer to the question, the problem of what is 5/12 divided by 3/4. And actually, okay. So the next one, what do we need to do to that to be able to work it? Same thing. We got to flip the one, the divisor, the 6/7. We got to make it 7/6 and then divide, multiply instead of divide. So let's do that. We'll go 4/9 times 7/6. So let's see, can we cancel? We can. The 4, 2 goes into it 2 times, the 6, 2 goes into it 3 times. So then we're going 2 times 7 is 14 over 3 times 9 is 27. 27, and that does not reduce any further. So the answer is 14/27. Next, we got 16 divided by 3/32. 1/16 divided by 3/32. Interesting. Okay, so to do that, as we know, we got to invert the 3/32 into 32/3. So it's, again, simple multiplication problem of 1/16 times 32/3. 16 cancels, goes 1. 16 goes into 32, 2. So then it's 1 times 2 is 2. 1 times 3 is 3. 2/3 is the answer. 2/3. Easy peasy. Anybody have any questions? This is pretty easy, huh?
Yeah.
We'll do one more, and then I think we'll probably do some uncommons on the next page. So 12/17 divided by 4/5 means 12/17 times 5/4, right? So can we cancel? Yes. 4 goes into 4 1 time, 4 goes into 12 3 times. 3 times 5 is 15, and 17 times 1 is 17. So the answer is 15/17. Weird fractions, right? They're definitely weird fractions. So I'm not going to go too much farther than this, but let's jump down to this one here. So this one, since we can't use whole numbers, we've got to make them into uncommon fractions. So what's the uncommon fraction for how is the whole number 4 represented as a fraction? 4/1. Exactly. So 4/1 times 8/3, because we inverted, right? And nothing can cancel, so that's 4 times 8 is 32/3. Now that's a improper fraction, 32/3. So let's divide the 3 into 32. I know 3 goes into 30 10 times, so it's 10 with 2/3 left over. 10 and 2/3, that's the answer. Next. All right. Let's convert some of these mixed numbers and then do the math. So we'll do an easy one. 23/1, right? Times, but before we can invert the fraction, we got to make it, and we got to take this mixed number and make it an uncommon fraction. So to do that, 8 1/3 is how many thirds?
25 thirds.
25 thirds.
It's 25 thirds, right? Because 8 times 3 is 24. Then add the other third, that's 25 thirds. We're going to invert it and make it 3/25. And then we're going to do the simple multiplication. There's no canceling. So 3 times 23 is 69. 1 times 25 is 25. That is a uncommon fraction. So we got to change it to a whole number. Or we've got to change it to a mixed number fraction. So 25 goes into 69. 2 times 25 is 50. So it's 2. And what's left over is 19/25. So 2 and 19/25 is the ultimate answer that we want to get to. Let's skip ahead to this one down here. So 4 3/4 as a fraction, what is that? What is 4 3/4 as a fraction?
19/4.
Exactly, 19/4. And we're going to do times, but let's find out 2 1/8 as a fraction is what?
17/8.
But we're going to reverse it into 8/17. And we can cancel. 4 goes 1, 4 goes into 8 twice. Then we're going to multiply across. 2 times 19 is 38 over 1 times 17. 1 times 17 is 17. 17 goes into 38. 2 times 17 is 34. So it's 2 and 4/17 left over. Got it? Everybody clear on that? Nobody has any questions? Getting it? Okay, good. I think this is probably a piece of cake for everybody. So let's go down. We'll skip to a 18, which is hopefully a really, really hard one. So 5 2/3, what's that as a improper fraction?
17 thirds.
17 thirds.
Exactly, 17 thirds times, first of all, what is 18 1/2 as an improper fraction?
37 halves.
37 halves.
Exactly, 37/2, and we're going to change it to 2/37. No reducing there. 2 times 17 is 34, and 3 times 37, right,
111.
is actually that 111. So it's 34 111ths is the answer. It's an oddball fraction, but it is the fraction. Just like that test. There's actually, even though it says the last page of that test, so some of you took the test, some of you didn't. It says it's worth 4 questions. Now they said 68 through 72. Really should have said 68 through 71. 68, 69, 70, 71. That's 4. So there's really 71 questions in that test. 71 questions, not 50, which is worth 2 points each on a 100 scale. Because when we get into decimals, which we're about to, decimals are all about 100. Tens and hundreds. We're getting into a much easier way to look at things than I think than fractions will ever be. But back to 19.
I've got to say, I've never taken a quiz that long in my whole entire life.
Yeah, calling it a quiz is stupid.
71 questions.
He actually called it a test. When I wrote it up, the test, I changed it to test rather than quiz. I mean, it's a test. Test is a test. Quiz is a quiz. But yeah, I thought it was kind of crazy.
Quiz is usually like 10 questions.
Yeah, I know.
10, 20
So just deviating for a second about that, because you were there. No. So it's really just the two of you guys. So we're not going to spend too much time.
Some Zoom people probably.
But I had to use my ability to change things to decimals to do percentages. So I had to know if you missed 17 out of 71, that's 44, that's 54, it's 54. It's 54, right? And that 54 divided by 71 gives me the percentage, gives me the decimal figure, which in this case would maybe 0.76. That's 76%. We're gonna get to that really soon. How many 6.5-inch blocks can be cut from a 47.5-inch board? Well, so how do we want to say that? We want to say 47.5 divided by 6.5, correct? Okay, so let's change 47.5 by going 2 times 47 is 94 plus 1 is 95. So that's 95 twos, 95 over 2 times, we're going to change 6.5. That's an easy one because 2 times 6 is 12 plus 1 is 13. That's 13 twos. So it's going to be 2 over 13. We have to invert there to get the reciprocal. And then it's 2, those cancel each other out. 2 goes one time, and 2 goes one time. 13 does not go into 95. So it's 95 over 13. And we can't leave that. We have to make that a regular, that's an improper fraction. We have to make it a whole number, a mixed number. So we go 13 into 95. Let's see. 13 times 6 is 78. 13 times 7 is 91, right? 13 times 7 is 91. So let's do that. So 7 and 91 from 95 is 4. So 7 and 4 13ths is the answer. Wish I could do this on the board, but I don't want to go back and forth on this.
So it
Okay.
would be 7 blocks.
Say again, please.
So it'd be 7 blocks that you cut.
Yeah, you could cut, right, 7 and, well, no, you can get 4 13ths of a block too. So yeah, you're gonna get 7 blocks with 4 inches, right? With 4 13ths left over.
That's correct.
So you're gonna get I'd have to figure, well, it's easy to figure really if you go 7 times 6.5, right? It's 7 times 6.5. So 7 times 6 is 42. 7 times a half is 3.5. So 45.5. So you're gonna have 2 inches left over. That's a pretty good. That's pretty good. You cut the board and have 2 inches of waste because by the time you make 6 cuts, you're gonna have already. If you make 6 cuts, you're gonna already gotten rid of 6/8. So you're gonna 3/4 are already gone. So that only leaves you an inch and a quarter to play with. So that's cutting it fine, but that's fine. You know, when you're doing stuff like this in the real world, and you're trying to figure out how many cuts you're going to get out of this, you don't want to go to the gnat's ass. You just don't want to do that, right? You want to give yourself a little bit of waste, but you want to do less waste, right? We all want to do less waste. And we're going to do less waste, but right now we're going to take a break. It's 7 o'clock. Come back at 7:15 and we'll pick up where we left off.
Pause the recording.
Classes we are. You guys, come on back. Come on back, please, my Zoom people. Michael, Eric, Joel, Brandon, Matthew, Javier, Zach, and Miguel. Miguel, does anybody else besides me know what an animal Miguel is? He works full time. In Santa Maria, where are you working now, Miguel?
Right now, we just started a flooring job in Napomo.
A flooring job in Napomo, and he comes here for class. And you come to Santa Barbara a lot too?
Maybe just for school, not too much work. Most of our work is San Ynez.
San Ynez, yeah. Oh, that's still. Well, I'm glad
We
you're
got-
taking this class, man.
Yeah, this and then 3 other classes.
Really, man. You're an animal, Miguel. You probably already do that. Okay, so let's go back to this book. Here we are. Now something. Sink my teeth in a little bit. We're going to use the stairs shown below to answer questions 20 and 21. So the stairs have a total rise of 116 inches. What's the riser dimension? Well, let's count them. Okay. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 risers. How many treads then? Exactly. One less tread than riser. And if it's 116 inches, basically, do we want to know what the riser is, or 16 of them? We're going to be dividing 116 by 16.
10.
Yeah, no kidding. 10 inches of rise, right? No, that's not, that'd be 160 inches. That'd be 160. So I don't know where the fractions come in here, because it's 11.6, so it'd be 11 and not quite 5/8, 11 and 9/16. That can't be right either. 16, no, that's not right. I was thinking of 11 into it, so. 29/4. I gotta get my phone. What's 29/4? Where's the 29/4 come?
Well, if you do it 1/16 and 16/1, you just do 1/16/1 times 1/16. Cross cancel, it's 29/4.
Which is what?
It's gonna be.
Which is the perfect. Pleasure. I gotta get my phone so I have a calculator handy.
Works like a charm for 18 years. Yeah, it's all fine.
Remember, did you guys about losing my last phone? I lost it in that car. A black phone, black upholstery, and black carpets. It was in my car.
Did you find lots?
And I found it like after I bought the phone a couple days later. Oh, just laying there amongst all the other black stuff, the black bag with the, the sunshade goes in.
And you still got a black phone case?
I got another black phone. And I also trying to remember not to ever set anything down in an unfamiliar place, ever. It's dumb. But known to do dumb things. Okay. So we figured that one out, right? 7.25. I like it. All right, the stairs have 157.5 inch total run. What's the tread dimension? Well, we're going to divide 157.5 by, what do we say, 15? Yeah, divided by 15. Okay. So that's 15/1, and then the 157.5 is 2 times 157 is 314 plus 1. So 315 twos times 1/15, because we have to invert it, right? So it's 315/30. That should be easy enough. Should be 10, what? 10.5, right? Which is perfect. 7.25 rise by 10.5 inch tread. That's a good one. That's great. Because what's the magic number on unit rise, unit run?
17 to 18.
Say it again.
17 to 18.
Very good. It's pretty much 17 to 18, 17 to 18.5, 17.5 to 18.5. 17.5 is what, if you got it to 17.5, you nailed it. Nailed it. So a really nice tread is 7 with a 10.5 inch tread. So 7 inch rise with a 10.5 inch tread. So that's our tread dimension. Now, a standard concrete block measures 15 5/8 using a 3/8 mortar joint. That was on the test. Oh, but I took it out. It was an ambiguous question. Lou?
Ben brought up a good point while you're reading your phone. You never said what you did that worked for you in the beginning of class, and we're curious.
Oh, what it is?
Yeah,
I take psyllium husk, 3 tablespoons every day. I had a colonoscopy 2 Decembers ago, and I mentioned to the guy, like, what should I do for occasional, constipation? Too bad I have to record this, but he said, just take psyllium husk and buy it at Trader Joe's. And so I started taking it, and I take it every day, and it's the greatest thing in the world, man.
helps keep you regular.
Yeah, as regular as a clock. And as you age, everything slows down. You really have to kind of watch what you eat and stuff like that. It's a drag. I hate to be full of it. So standard concrete block measures 15 and 5/8. Use a 3/8 mortar joint between each block. How many blocks are needed to lay one row on a 192-inch foundation? So first thing we got to do is add 15 and 5/8 and the mortar joint, right? What's that at? 16, right? So 60, that's 16 inches. So to find out how many blocks we need in a 192-inch foundation, we're just going to divide 192 by 16. And I don't know why we need to change it into fractions. I'm not going to. I'm just going to take my calculator and go clear 192 divided by 16, 12 blocks. That's 12 block run. And then you can just prove that if you're wondering, right? You can go, okay, clear 12 times 16 equals, well, 192, I was right. A roof that measures 187 inches. I fell today too. That's why I'm all cut up. My knees are all skinned up. Looking for that stupid mask store. They've cut out the sidewalks so wheelchairs can get down. And so they've got this 0 to 3 inches of curb. I happened to look around while I was walking down that thing and just my nose down. And the interesting thing was there was plenty of people around. Do you think one person offered to help an old guy that just fell down? Not one, man. It was like I didn't exist. It was really kind of weird. But
Because you didn't have a mask.
it's true. It's like, get away from him. He doesn't have a mask. Throw a mask at him. A roof that measures 187 inches from eave to ridge is shingled using a 5.5-inch exposure on each row. How many rows are needed to cover the roof surface? How do we find that? Don't we divide 187 by 5.5, right? Yeah. Okay. So we'll go ahead and since we're on, the fractions, we'll do it as a fraction. So we're going to do 187 over 1 divided by 5.5, which is, as an uncommon fraction, 2 times 5 is 10. Add the 1/2, that's 11 halves. We're going to reverse it to 2 over 11 and then multiply. 2 times 187 is 360 plus 14. That's 374 over 11. We've got to turn that into a whole number or a mixed number. So we just take, what is it? 374 over 11. We take 374 divided by 11. It's 34 exactly. Right? It's 34 times 11 equals 374. Yeah, 34. Okay, so you need 34 rows.
Rodney,
Yes.
isn't that for only half the roof?
Yeah. it
It
is.
says from, okay.
To cover that roof surface. That's a good point. Given that it says it has a ridge, kind of leads me to think it's a gable, but I don't know yet. On a shed roof, a gambrel roof, hip roof. No, so ridge really kind of indicates it's a gable. So you're absolutely right, Zach. That's a good point. It's like, yeah, it'll take 34 rows to do one side of the roof, but if it's the other side is exactly the same, it's an equal gable. then it's gonna take 68. So good point, Zach. Thank you very much. Where do you use your head there?
What's the difference between rows and squares, roof squares?
Well, the roofing square is 100 square feet.
Okay,
So if you want to figure out how many roofing squares, you'd have to figure how many shingles cover 100 square feet. That's another problem, which we can do. But I'm right the same. Right? The roofing square is 100 square feet.
Okay.
So roofs are called out in squares. So, 3,000 square foot roof totals 30 roofing squares.
Okay.
Now, you want to know how many shingles to do a roofing square, and there'd be a formula for that, right?
so it just means literal rows of shingles. is the
Yeah,
problem.
literal
Not-
rows. 5.5 inches of coverage, you're gonna need 34 rows. of shingles. We don't even know, we know there's 34 rows. We don't even know how many in a row. So we'll need more information.
Okay,
So how many risers are in a set of stairs if the total rise is 92 5/8 and the risers are 7/8? So that's a problem where we take 92 5/8 and we divide it by 7 1/8. And to do that, we make the 92 5/8. Is this projecting? Yeah. We make the 92 5/8 an uncommon fraction. So what's 8 times 92?
736.
Say it again.
736.
736 plus the 5 on top. That equals 741 over 8 times 7 1/8 as represented as an improper fraction. Uncommon fraction, improper fraction, uncommon fraction. Is 7 times 8 is 56, plus 1 is 57. So 57 over 8. So 741 times 57 over 8 times 8, which is 64. And I'm not going to do the math. We know how to do that now, right? If we have any questions, I'll do it. Any questions at home, I'll do it. Let's just move on. Now, okay. So in the railing system shown below, each baluster measures 1.5 inches wide. Assuming equal spacing, what's the distance from each post? Forget this thing for a minute. Let's go to the board. Let's go to the board.
I got a weird.
Okay. Balusters. Balusters comprise a balustrade. Balustrade is comprised of balusters, rails, usually top and bottom rail, but not always. In this case, what I'm going to show you is top and bottom rail, and then slide top rail, finish top rail, and millworks. So this is the vernacular of staircases and guardrails and handrails. Stair systems. Pretty much all stair systems, if they're not captured, if they're captured wall to wall, they need grab rails. If they're over 44 inches wide, they need 2 grab rails. If they're under 44 inches wide, they need 1. If they're open, they need a guardrail and balustrade. With a cap on it. We're going to talk about a level balustrade on a level deck. And I don't know that I'll take the time to do this deck for you, but I got a deck. I got a video I made on YouTube. It's in my YouTube videos about the ideal deck. So just talk a little bit about it, and then I'll show you the balustrade thing. If you're building a deck on your house, it's a level deck. And for purposes of argument right now, there's no stairs or anything leading off the deck. It's 2 or 3 feet in the air. You access it from your house. So that deck needs to go out X, and then it's X long. And let's say you have options. You have the room to do it like you want. I don't like to space rules much greater than 6 feet apart. So let's make this deck huge and make it 12 6 foot increments. Make it 12 by 12 by 42. So we're building a deck that's 12 by 42, connected to the house. This is the house. There's a bypass slider. The deck's gonna come in. It's gonna come in a little bit, say 3.5 inches. It doesn't really matter at this point. It's gonna be 12 feet out, 42 feet this way. And in 6-foot increments, you're gonna want a newel, and 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 a newel. And then in here, 42 is going to give you 7 spaces, right? 7 6-foot spaces. So that's a total of 8 balusters. So there's one on either end. So there's 6 in the middle. So 6 in the middle would be. So something like that. Obviously not to scale. And this is not to scale at all. But what I'm showing you is that if you have the option to do the layout, and you have some room, you can lay out a deck so that when you put the balustrade up, the guardrail, you set the newels, you can run them all a while, then cut them off level. You can make it so this is all the same. So you could make this, let's say you wind up getting this to be 70. I think it's probably going to be 68. But you can lay this out on paper so that every single spacing, newel to newel, is the same number. Now, if you can do that, you can build a deck so much faster. You can build a guardrail so much faster than you could do it in any other way, where you're building different size balustrades. Because a lot of people do that. They don't get accurate enough. So they may be building a 68.5-inch balustrade, newel to newel. And the next newel to newel is 71. The next newel to newel is 70. The next newel to newel is 67 and 3/8. You know what I mean? You see that all the time. Because they don't think about the layout. Because a lot of people build hand with it. Like, I'm on a job. I'm not on a job, but assessor. One of my students got a place to do John House. He's running a job. It's a $7 million construction. It's probably going to go to $10 million. This thing is cat's pajamas in every way. The plans are this big, and the engineering, and they have meetings with the architect once a week. It's just as jazzy and as pro job as you can think of. And they're doing his all his handwork. They're in the closets. The walk-in closets are literally half the size of this room. His closet and hers the other. Huge walk-in closet. And there's a little bit of a plan on the architectural. It doesn't show much. So they're in the closets, waving their hands. Now, does that mean anything? Yeah, here's what it means. It means I want this. I have some idea. Well, if you have some idea of what you want, to be able to communicate it to me, the builder, or any other builder, you can't do it with a series of hand waving and pointing. You just can't do it. I mean, amazingly enough, you actually can do it and it does get done, but it's super inefficient. And it doesn't allow you to design, which is what drawing plans does. You actually make the room real on a piece of paper this big, and then you design where this stuff goes, and you get a feel for it, and you do erasures, just like we're doing on yours, and make changes, and see how it all works, right? So if you can design a deck where you can get your newel posts, and your newel posts are 4x4s, right? So if this is your deck, doubler, edge of the deck, cut away through, right? Deck boards are running this way. And your newels are 4x4s. They run wild and they're let in, so they all index. And then you cut them off dead level because you run a laser around it after you run them wild. They're dead level, dead plumb. You cut the tops off dead level. And if this is, one of these in the mid, you're going to have a 3/4 let in and a 3/4 let in. And down here, you're going to have a by inch and a half. Inch and a half. Here you're gonna have 4-inch minimum. And that's gonna be let in, and that's gonna be let in. Now this is your balustrade. So you've laid out your newels, your 4x4 newels. You've run a laser around them, so you have a level line, so they all come down and they get cut. You've already done this cut to let them in, because you're bolting like this. You're through bolting. All the way through. Nut and washer. 2 bolts, strong as it gets, right? Comes off because you run a level line. Now you can take them in the shop, cut them level, do your let-ins, 4 inches is the magic number. You cannot have a space greater than 4 inches on a guardrail. Anyway, that's IBC, that's UBC, that's International Building Code. UBC is the Uniform Building Code. It's our local codes. If you pull up, I have a handout for guardrails. 4 inches is the magic number. You can't be greater than 4 inches. Okay, so this guy has got to be 4 inches or less between the deck and the bottom rail. And if that deck, if you build your deck level, then your 4 inches is consistent. If your deck is not level, if it runs downhill this way, then you better get your 4 inches here so that when you come back up level, it's less than 4 inches, not 3. If the deck runs downhill this way, if we're looking at the deck, right, looking at the face of the deck, and it runs downhill this way, and you start with a 4-inch space here, and it runs an inch downhill, and it's 42 feet, which is not uncommon, or even 2 inches, then you're going to have a 5 or 6-inch space here that's going to be totally not good and unacceptable, and you're out of code. So you start your 4 inches here, and then work your level back. If it's 2 inches out, you're going to have 2 inches here, but you will not be greater than 4 inches. Now, the balustrade. There's more than one way to do equal spacing in a balustrade. I like to do it the center method, which means you have to burn half a baluster at each newel. Here's what I mean by that. So if your newel is, and for purposes of argument, let's say that all your newel spacing is 68 inches, just for purposes of argument. Every one of them. So you're going to make the same baluster, same balustrade. You're using 1.5 inch clear redwood for your balusters, 2x2s. You're using a 2x4 top rail redwood and a 2x4 bottom rail. And then you're going to cap that with a 2x6. So it's going to look, your rails are going to go like that, going to go like that. This is going to be let in as well. Bottom rail is going to go like that. Deck's going to keep going. If we were looking at this way, right, the space, and then your balustrade, it's going to be 2x2s with equal spacing. And that spacing has got to be what?
4 inches again. Is that 4 inches again, or?
Less than 4. 4 or less. And so here's the formula. The formula is, it's the newel to newel dimension plus 1 baluster. That's how you start, right? So that equals 69.5. You with me? Everywhere our newel to newel, post to post, newel to newel is 68 inches. We're going to add 1 baluster to 1.5 inches. So that's going to make it 69.5. That's the number that we're going to work with. Now we're going to take that 69.5 and we're going to divide it by 5 1/2. 5 1/2. Why? We're going to divide it by 5 1/2. We're going to divide it by 5 1/2 because a baluster plus 1.5 inches plus a 4-inch space is 5.5 inches. So somebody with your calculator, what's 5.5 into 69.5?
12.6.
12.6? Is
Is that,
that right?
were you expecting a decimal?
Oh, yeah, decimals point. We'll jump right into decimals, but I thought this would be a good time to show you baluster spacing. So So the clear 69.5 divided by 5.5 equals 12.6. So no matter what number you come up with, it doesn't matter. You're gonna go to the next number. You're gonna round up. Even if it's 12.1, you're gonna round up. Okay, you got it? Because that means you're gonna have less than 4 spaces. Now, if that number comes out dead even, that's the number you're gonna use. So that's the number of spaces. But in this case, it didn't come out dead even. It came out more than 12, 12.6 or whatever. So it goes up to 13. So you do your first division, 5.5 into the number, you get a number, and you bump it to the next number. In this case, we got 12.6. So there are 13 centers. We're working with 13 centers. 13 centers is going to be 12 balusters. 13 centers. And here's how you get the centers. Now that we know there's 13 centers, we're going to take 69.5 and we're going to divide it by 13. Now we're going to get the real number. So you understand where we got 69.5, right? 68 plus 1 baluster, which is basically a center of a baluster, half a baluster, 3/4 into this post, half a baluster, 3/4 center into this post. So 69.5 divided by 13 spaces equals 69.5 divided by 13 equals. So by the way, we haven't got to decimals yet, but I'm assuming that you understand that a half is 0.5 in decimals. And that as we get into decimals, just a quick thing in decimals, any fraction is turned into a decimal by dividing the bottom number and the top number, the numerator by the denominator. I can't remember which is which. I'm confused. The bottom number, say again.
Numerator is a couple.
Okay, so the denominator is the bottom one. So you divide the denominator and the numerator. Just remember the bottom and the top, any fraction. And that's how you make a decimal. So 2 into 1 is 0.5, and that's 0.5, 50% is a decimal 0.5. So in this case, we came up with 13 spaces is 69.5, came out to 5.346. Okay, so 5.346. So that's 5 plus 3/8 is 3/7. 5/16 is 23.75, 28.75. So I like 3/8. 3/8 is 0.375. We have 0.346. So it's a skosh less than 0.375. Not much. We didn't come up with an exact number. We're getting close. We're close enough. We can lay out our centers on one of our rails and see if it works. Because we're not doing anything yet, we're doing layout with pencil marks so that you can sand off. So, but our magic number is 5 3/8. 5 3/8. Because our 5.364 equals 364, 346, it's close enough. 346 is close enough to 3/8. We're going to go with 3/8. We're going to call it a minus. So we do our layout. I'm going to hit my tape with 5 3/8 and go just a skosh that side of the line and see how it works out. And then we're going to start laying out centers. We're going to take this top rail, which by the way, the top and bottom rails for 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going to cut 18 of them, 69.5, right? Because we've laid this thing out so we can do that. We're going to build 9 balustrades all the same. So we cut all the rails the same. We'll take one rail, a 16.5-inch rail. We'll throw a tape on the end of it. And we'll start laying out centers. Lay out centers. We'll go 5 3/8 minus. And then we'll go 10, you know what I mean? Or I'll go to the 1 and go to 6. You know what I mean? So measuring and calculating, if you were laying out centers like that, and you don't want to add 5 3/8 to 10 3/4 to 16 1/8, you know what I mean? You don't want to do that math. You're going to go, you can either make a little storyboard, you can take a piece and cut it 5 3/8 minus, put it on the end of your board, make a mark, make a mark, make a mark, right? Or if you're measuring 5 3/8 minutes, you don't want to put it on this. Burn something. I usually burn 1. If the 1 isn't that visible, I might even burn 2. So if I burn 2, I put it on my mark at 2, and then I measure to where? 7 3/8 minutes, right? And I go over 2, I measure 7 3/8 minutes, which is really 5 minutes, right? And so if I've done it right, my last one on my 69.5-inch rail is 5 3/8. And if I'm burning 2 7 8, right? And my rails were I've already burnt. Because the rails, because I've done 3/4 lead ins, looking down on this, 3/4 of an inch, those rails are gonna sit in here, then they're lead ins 3/4 of an inch. So they're 68 plus 2 3/4 lead ins, they're 69.5. I have let them in the exact center of the baluster. So that I don't have to put the tape on this and burn 3/4 of an inch and put 3/4 of an inch as an imaginary center. I just do it on my rail. I just hook my tape on my rail. And I'm good enough at math. I probably would go 5 3/8, 10 3/4, 16 and just start adding 5 3/8. And then if it didn't work out, if I had my last one was greater or less, I would just go back and tweak a little bit the numbers until it did work. So it all was 5 3/8. And if your centers are off a 16th, I guarantee you no one will know. But they will also at 5 3/8, guess what they'll be? They'll be 3 7/8. The spaces will be 3 7/8. They'll be 5 3/8 less a half a baluster and a half a baluster, because you're going to lay out centers. So 5 3/8 less an inch and a half is 3 7/8. So you're under the 4. You hit the magic number because you did the math. And you got the spacing and you went up 1. So you know that this number is going to give you less than 4 inch spaces. You know you're covered. You just want the same number. Get the same number. And you just got to remember to burn the 3/4. But if you do it the way I do decks and let the top rails in 3/4, you don't have to burn shit. You just throw your tape on the end of that rail, because that rail represents half a baluster burned, an imaginary center. Because you get guys, good carpenters. I have had good carpenters, and I was explaining this until I was blue in the face, right? Come back and I'd have equal spacing until the end, and then I have these 2 narrow spaces, because they would do it with 68. Now you could do it with 68 and figure out how many balusters. What did I say, 7 or 8 balusters? 7 times inch and a half is 10 1/2. Take 10 1/2 from 68 and then divide that by this amount of spaces. 10 spaces or whatever it is. You can do it that way too. So you can do, space, baluster space, baluster. I like the layout centers, so that when I'm ready to nail, I've got my centers laid out. I flip over my 2x4s are laying here like this. My balusters are all laying in there. My balusters are sitting up. So on a 3 1/2 inch 2x4 and an 1 1/2 baluster, that leaves 2 inches, right? 1 1/2 from 3 1/2 is 2 inches. So it's going to be 1 inch on either side. So on a 2x4 rail, bottom or top, let's say it's the bottom rail, and you got an 1 1/2 baluster going to it. This is 1 inch. This is 1 inch. So I'll cut some 1 inch rippers. I'll lay 1 inch rippers down. So I'll lay my balusters on them, so I know they're centered on the board. And then I just galvanize finish ones and bam, bam, and I nail them looking down on it. If we were to look down on the top rail, and this were a baluster, I would nail there and nail there, so it can't spin. Nail them back. Galvanize, they're gone. Doesn't matter. You'll never see them from the bottom. From the top, it's gonna get cap rail. It's gonna get a 2x6 cap rail, clean, clear, regular 2x6 cap rail, lighter than the corners. You'll see the lead-ins. The lead-ins are beautiful. You guys, I did this in my deck. I should keep a picture because the lead-ins look really nice. You look at this thing and go, wow, they let that stuff in. You see stuff. That also allows you to make a really well-wrapped, well-done handrail, guardrail. And when you nail the top rail on, so if you look at a newel post that from the top, you cut out this much and this much. You left 2 inches of meat in the middle, right? And your rail is here. And below it. So you can screw or nail right down, toe, right down into that mill post, because your 2x6 cap rail is gonna cover all that, you never see it. Keep it from the elements and keep it from the visual. So all you'll see is that really clean, and you can come up from underneath this thing and screw or nail, clamp down, screw from underneath, so your top rail is completely blind. There's no fastener shown. This is the way it goes. You just make that top rail as smooth as a baby's butt, rounded edges and splinters. You want to get up against. Any questions about that?
What do you like to treat it with after?
Well, that's a super good question. That's probably why you got 100%. I like Sikkens. That's like KKENS. It's sold under a different name, but if you say Sikkens to St. Louis Paints or anybody, they'll know. It's made in Sweden. It's a heavy-bodied stain. It's good for a couple of years. But you want clear redwood. If it's not clear, if it's an older deck, you need water blast it. Use a pressure washer to let it dry. And then go to Sikkens. Sikkens has a teak color. It's really, really good. That's what. See, the thing of it is that you're staining wood. So redwood's okay outside with nothing on it. It'll just gray out, right? It just goes across. And it's UV and moisture is not good for any wood. So whatever you put on is going to be good. But anything to the exterior is not going to stay. It's going to go away in 3 years. I get 2 or 3 years on it. It's looking good. But think of wood to the outside as being naked. Think of a naked person outside the elements. Your skin is gonna take the elements. It's gonna get sunburned. It's gonna get windburned. It's gonna maybe get wet, shrinkled up. So what protects you is your clothing. So just like wood needs clothes, it needs something between its living cells. They're dead now, but they were living cells, but wood's still active, wood's still alive even after it's cut. It expands and retracts, right? You need something physical between it and the elements. And that would be stain would be the least you could do. Because you want to use a heavy bodied stain because it's the pigment, it's the actual material between the UVs and the wood that does the job. That protects the wood. Makes it look good, yes, and it protects the wood. So guess what protects wood the best on the outside? Paint. There's nothing better than paint. A coat of primer or 2 coats of finish, and you've got 2 or 3 mils of protection from the UVs. And paint, you can get 5-10 years out of a paint job. But redwood decks, mine's not painted. Mine's done in Sikkens and looks great. I've done it twice. I did about 5 years out of it. And it didn't look all that good. I don't know what I did. I use like a Cabot stain initially because I probably did 20 years ago.
What would be the best thing to do for like the interior of the room? The stain or paint or
Paint.
Yeah.
Paint. It'll protect the wood the best. If nothing else, a linseed oil, anything you do will help the wood. It'll put some layer of protection between it and all the crap you're going to put on it.
do you have to sand it before doing?
You gotta clean it. You just gotta clean it, wire brush it, maybe sand if you like, but hose it, and wipe it dry. Just when the oil's off, you want to get the dirt off. And then you prime the paint. Prime the paint you just can't go wrong. You're helping the wood last long. If you do what you're talking about, remember I said put that geocloth in, that still allows moisture. The wood's just gonna rot. Yeah, it's not gonna rot right away, but it will rot. So if you don't line it with something that resists or keeps the moisture away, you can line it with Tyvek. Tyvek's incredible, really, because Tyvek, you can't take a cup of water, and throw it against Tyvek and have it finish. But you can blow water vapor with Tyvek and it will right through it. So Tyvek allows water vapor that might get, Tyvek is house wrap, the DuPont house wrap, which we're pretty much required to do now. It will allow any water vapor that gets trapped in the wall, it will allow it to come out. If it comes out stucco, the stucco has a weak spot, you'll hit that stucco, go down the stucco, because water is affected by gravity, and you've got a weak screed at the bottom, that has holes. So that water will won't stain your wall and cause mold and rot. Because that's what water does in closed spaces. It causes mold and rot, and those are not good things. for me. So, something to think about. And I know I got off topic quite a bit, but if you remember this about the decks and the balustrades, you were doing it on that. You could just plan it so that your newels are the same distance, so you're making really 9 balustrades. So if I did that right, I'd be making 9 balustrades, 18 the same cut. Put a stop block up at 69.5 inches on my chop saw, just bam, bam, 18, 2 minutes, and they'd be perfect. They'd all be 69.5. And then I've already figured, based on 36 for my guardrail height, I think it's 42 now. And it's dead level, right? Because I've cut those things out dead level. And so the bottom rail is cut based on the top lead and that lead. And so that's a level, parallel, complete run. So you can cut all your balusters. You figure your baluster height, whatever it is, set a stop up in your chop saw, boom, 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 and you just cut 81 balusters. You can really get efficient. And you can really get accurate too. And it's all on plan. Now, if you screw up, you go, this one's an 1/8 inch. You gotta do 9 at 69.5 and 1 at 69.5/8. But you really try to. You can't, and you have some slop too. That's the cool thing when you lay this out, because you can't have this greater than 4 inches, this space here. So this is back 4 and this is back 4. That's like 2 inches in between. So you can move these corner ones in or out to get the spacing. Because ideally you want to come. You try not to get 68 and 11/16 or 68 and 3/16. Try to get some equal numbers. Questions about that?
On this, we really need to go into decimals. Well, my question was, let's say that you have a stubborn client who wants this deck with this dimension, right? So he says, I want it from this mark on the wall all the way to that mark on the wall. And then it is that distance, let's say, is 69 or 69.25. Whatever it is.
Yeah.
And then, so you make the project for him, then you come back and say, this is going to cost you $100. And then he says, well, that's too expensive. Will you use this as a selling tool, for instance? Okay, then if we just narrow it.
Here's the thing, Ben, I would, when he gave me his dimensions, I can build it to his dimensions.
Right.
So that's how I did it. I did it for myself to do it as efficient as I possibly could. And to reflect on my price, and hopefully reflect, and I would explain it to him. This is how I'm gonna build your deck. And if he's got any kind of sense, he'll see the wisdom of doing it.
Okay.
So you can do it with any dimension. You just have to, like, if this is 6 feet, I don't like balustrades much over 6 feet. So if this was 8 or 9 or 10 feet, I would just divvy it in half, put a wall in the middle, and then just start. And you may, because this is a short run, you may have 1, 2, 3, 4. Let's say this is longer. This is like 8 feet, and you wind up doing this. You're going to have 1, 2, 3, 4 balusters the same, and then 9 balusters different. 6, 7 balusters the same, and 4 the same. And that's you can do that at any deck, virtually anything. And then if you've got stairs leading down, you just got to factor that in. And you do all of this stuff. Not on the site. Yeah, there's a lot of stuff that on the site you make changes, but you do it all on plan. Make yourself a plan and try to stick to it, because you can work out a lot of BS. You stick to the plan. You know what Mike Tyson said about a plan, right? Plans are great until you get socked in the face. Everybody's got a plan. Okay, so let's just see what decimals is all about here. We'll do a little bit of decimals and then we'll get out of here. I can only take so many numbers. So much numbers. Okay, remove the pen. View. Gallery. Let's share. Okay, so in this railing system shows each baluster measures 1.5 inch wide, which we just did. Assuming equal spaces, what's the distance between each post? I'm not gonna do that. I'm not gonna do that either. Tell me if you want me to do any of these problems. Anybody chime in if problem intrigues you or it sounds like a problem you want to see how it works.
We
Like,
can't see.
oh, sorry, guys. Sorry at home. The guys, your classmates are taking care of you. Did you? I forgot about Zoom. Did you guys see that? Did they see that? The board?
Yeah, we can see most of it.
Okay, on, okay, it's on. We still got one light? Yeah. Okay, good. It'll get darker. It'll get darker so everybody can see what the Zoom class sees at home. Zoom, what will we do without Zoom, huh? Mike, Eric, Brandon, Adier, Matthew, Joel, Zach. I don't know what we do. Okay, so is it up? Is it showing? All right. So a carpenter worked 17.75 hours and he grossed $4.26. Well, I'm interested. What was his hourly wage? Well, how do we do that? We're going to take 17.75 and we want to divide it. No, I take it back. We want to divide 426 over 1 by 17.75. We're going to make 17.75 an improper fraction. How do we do that? 4 times 17 is 68, plus 3 is 71. So that's 71 fourths, which we're going to reverse to 4 over 71. So the answer is 1 times 1 is 71, and 4 times 426 is 1704. Is that right?
You can cancel.
Oh, yeah, you're right.
26 and 71. Goes into 6 times.
It does? Okay, well, that's great. 71 is 1, 426 is 6. I love that. So instead of that, all that BS, it's 6 times 4 is 24. That's the answer. You made $24 an hour. How do you feel about that? How do you feel about that guy making 24 an hour?
Should make more.
Mike, how do you feel about that?
I'd enjoy $24 an hour.
Miguel, how do you feel about that? $24. Mike, how do you feel about $24 an hour?
I definitely would enjoy $24 an hour.
All right, well, good. See, that's what I needed to hear. So, so around here, if you're a journeyman carpenter, it's really hard to take the title of journeyman unless you've been through an apprentice program. But if you know how to form, frame, finish, cut roofs and stairs, I'd call you a journeyman. And if you're tool, you got the tools. If I'm looking like John's truck, I'd call him a journeyman. There's virtually nothing carpenter-wise he can't do. Those guys, 24 is low, Mike. I hate to say it, but it depends also where you live and how long you've been with the guy, and if he's giving you steady work and that's what he can afford and what he charges you out at. But 24 is reasonable. So is 30, up to 30. Depending upon really skilled guys, 35. I was paying Cesar 50. I could turn him loose, run my job, pour the concrete, get the mixer there, direct the grading, get the trenches in. That was well worth $50 an hour. If you work for somebody, you're gonna get paid with a paycheck with deductions, or you're gonna get paid under the table. If you get paid under the table, hopefully you won't get 1099. You gotta think if you should declare it, pay the taxes on it. I would recommend you do that. The thing about paying taxes is these days, if you want to buy something on time, on credit, if you want to buy a new electric vehicle or a tool or something that you don't have enough money for, but you could buy it on credit, mostly what people want to see is your tax returns. They want to see tax returns. So, you know, I spent a lot of years of my life dodging taxes until I realized I need to pay taxes because I need decent tax returns. Like I just refinanced my house not long ago. And it wasn't a big loan. I think I was 150. But all I had to show was this income for teaching 2 classes and my social security income. That's all. Because my mortgage is $624. It went to 642. It went from 625 to 642. So it increased by $17. I pulled 26,000 out of it. But my income verification was my tax returns, and all they needed to see was the money I made on my social security and here. Because I paid taxes on it. And I paid taxes on my VRBO. You know, I paid $205,000 in taxes last year because I sold a property I held for 20 years and I made a boatload of money and I had to pay capital gains. And that's a whole other story. But, you know, after the pain of thinking about that much money going to the government, you know, I came back to, I made money. I made enough to pay the taxes. And I got, you know, I got a good tax return. I got tax returns so I could buy stuff. And it will allow you to expand if you go into business. And even if you're, you know, by yourself, having good tax returns and having showing a decent income, or at least showing income, getting a credit rating up there. All good stuff. All good stuff. Board measured, blah, 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 cut at 8 feet. There's the exam. Ooh, find the missing numerator? Oh, interesting. Okay. How would we do that? How would we find the missing numerator of 5/8 equals, how many 70-seconds does 5/8 equal?
45.
How did you get that? Who said that?
Zach, you take 72, divide by 8, you get 9. 9 times 5 is 45.
Exactly. Exactly. 45 over 72. And you can prove that it's 5/8 because that is a uncommon fraction. So it needs to be reduced. So in reducing that 45 over 72, 9 goes into 45 5 times, 9 goes into 72 8 times. There we go, 5/8. So you just proved it to yourself and to me too, and anybody else who's listening. Reduce 464 to its lowest term. What's 464 in the lowest term?
1/16.
You see that? 4 goes into 4 once, 4 goes into 64 16 times. Now we need to convert 38/7 to a mixed number. How do we do that? 7 into 38, right? 7 times 5 is 35. There's 3/8 left over, so it's 7 3/8.
5 and 5.
I'm sorry, did I say 7? I meant 5. 5 and 3/8 is 38/7. I'm sorry, 5 and 3/7. It's 38/7. Can't be 8s because it's 7s. Now converting 7 3/8 to an improper fraction, easy peasy, right? 8 times 7 is 56 plus the 3 is 59, so it's 59 over 8. That's an improper fraction. The lowest common denominator for the following fraction. So what is the lowest denominator? That's the bottom number that goes into all of these. Does 2 go into all of them? No. Does 3 go into all of them? No. Does 4 go into all of them? Does 5 go into all of them? No. 6? Yeah, does. Right?
6.
No, it doesn't. Does 48, does 48 work? No, 48 doesn't work. What the hell does work? 48, let's see, 9 times 6 is 54. Does 54 work?
No.
9 times 7 is 63, that doesn't work. 9 times 8 is 72. Bingo. 72. So we just kept finding, because 12s and 8s being even numbers, 8, 16, 24. We got to find one that 9 goes into, so that's why we're doing 9. So 72 would be the lowest common denominator. So if you wanted to add or do anything to those fractions, you got to convert them. So 7/8 is how many 70 seconds? Well, 8 into 72 goes 9 times. 9 times 7 is 63. So 63 over 72, right? Easy peasy. It's the same stuff, every fraction. Anybody have any questions about getting the lowest common denominator? Because to add fractions, that's what you got to do, unless you turn them into decimals, which I think we're going to get to real soon. Let's see, any outstanding problems here? None of it look all that hard to me. Anything look hard to you? Anything you want to solve that looks really hard? Anything that we haven't already solved? Ooh. Nah, I don't want to do that either. All right. Let's do this one. 21. So a surface planer, which we have over in the shop, we have a 24-inch Powermatic surface planer. Using a surface planer, a 3 1/8 inch board has 5/16 removed from one surface and 3/16 from the other surface. What's the final thickness of the plane board? We got to get the fractions right. So 5 and 3 are good. 5/16 and 3/16 is how many 16ths?
8.
8. 8/16 equals what?
1, 8.
1/2, right? 8 goes in 8 one time, 8 goes to 16 two, so it's actually a half. So we took a 1/2 inch off, and we got to take 3 1/8, and we're going to convert that to an improper fraction. 8 times 3 is 24 plus the 1 makes it 25 over 8, and we got to take away 1/2 of an inch. So this one is 24/6. That's 3 8/8, so it's 2 2/3 is the answer. Is that right? Oh, not 2/3. Yeah. That's right. Well, no, 3 1/8 less a half is 2 5/8. 2 5/8, which is 0.265, 2.265. Let's get to decimals. Let's just barely get to decimals, and then we'll call it. I'm fading fast. Decimals. Oh my God, here we are. We're decimals. We're not gonna do this tonight, but I'm just gonna go through the first page because we're gonna get out of here. It's already 8:15. But unit 11 is we're gonna talk about the basic principles of decimals, then we're gonna add, subtract them, we're gonna multiply them, we're gonna divide them. Key terms are decimal and decimal points. So if you've got the book, or if I can make it accessible on Canvas, read it up, and we'll whip through decimals. And then we'll start doing some, I took this plan here tonight. I didn't get to it, but perhaps next Thursday I'll get to it and we'll do some takeoffs. We'll do some square foot takeoffs, we'll do some linear foot takeoffs. We'll start using some of this knowledge we've garnered to come up with some real answers for potential questions that you might have on a real job. So any questions for me? Any questions? And Zach, is it time to turn off the recording?
Yeah, I suppose so.
Let's stop the share. We're all back together. So I got to tell you, you guys are really a pleasure. And for more than one reason, but here's the main reasons that you guys, all of you all at home, all of you that I can see, and all your names I can see, and everybody here, is that every one of you shows up. And I don't mean you just physically show up here. I get that you show up with what we're doing. I got eye contact, which is what's so great about not doing Zoom. It's hard to do eye contact. I gotta look there, but wait, I'm looking there. And And I just know that I have your attention, and that means a lot to me. And it means that I come here, right? And a lot of times I get people that come here, but they're not really here. And it just bugs the crap out of me. Every one of you is here, and I appreciate that. And I hope I'm offering you something, and I hope as we go, it'll get more real. But I like that we went through these basics. I'm liking this book. Keep coming back. It works if you're working. See you guys. Hey, see you next week, huh?
Thank you, Rodney.
Sure.
Thank you.
Hey, and any of you guys that did the test, we'll go over the test next Tuesday.
Okay, thank you.
Okay, and Joel, take good care of yourself.
You too. Thank you.
Yeah, expect
night.
progress reports.
The test includes